we would think the total surface area is one base plus, what do you know about each of these triangular lateral faces though, Jordan? They're all the same. So we have 5 triangles. And so that at least simplifies what we're looking for. Makes it a few less measurements that we need to find. And what's the area formula for this particular base shape? 1/2 SAN plus 5 times, and what's the area formula for the lateral face? 1/2 base times height. And let's see if there's any of this that we can actually fill in before we begin. So 1/2, what's the length of the side? 4. The apothem we don't know yet. Do we know the number of sides n? That's 5. Plus, I'm just going to multiply 5 times 1/2. Do we know what the base of the triangular faces is? Also 4. And do we know the height? No, not yet. Okay, so we have 2 pieces of information that we need to solve for. I'd encourage you to possibly redraw so that you can look more closely at the figures. Okay, so here's our base. When we look at our base, we want a reference triangle. We have the side of 4. In order to fill in this piece right here, we need to know the apothem. Do you recall how we can find the apothem? When you draw in the apothem, it does what to the base of this isosceles reference triangle? Bisects it. So we have a length of 2 here in this right triangle. So we now have a leg of 2, a leg of unknown side A. Do we know what either of the angle measures is? Either of the acute angles of this right triangle? Can we find those angles? Yeah. So what we can do here is, let's say we take this whole angle here. The whole vertex angle of the isosceles triangle is what fraction of 360? Okay, so the entire vertex angle is 1/5 of it, okay, and then we're taking half of that. So what is half of 1/5? 1/10. Now, does that make it a calculation you can do in your head? Yeah, what's 1/10 of 360? Okay, so we get this angle to be 36 degrees. And so now if we look at this acute angle of the right triangle, 36, we have an opposite side and an adjacent side. Opposite and adjacent is which trig ratio? The tangent. So we know that the tangent of 36 degrees is equal to the opposite 2 over adjacent A. Solve for A. We're going to move it out of the denominator, multiply both sides by A, and then divide by the tangent of 36 to isolate the A completely. And so we get A is equal to 2 over the tangent of 36. So let's calculate that. 2 divided by the tan of 36. We'll put it in decimal form. And we get an answer to be approximately 2.75. Now remember, and the reason I underline this and put it in a different color here is to designate when we actually go through and calculate the surface area, we're not just going to use 2.75. We'll use this exact answer. So we'll come back to this later. Okay. Next, we want to find the height of our triangle. Okay. So if we look up here in this figure, the height of our triangle is this measure right here, correct?
Yes.
Right, now when we're looking at this, once again we have this reference triangle. The height is the altitude of that reference triangle. And so what we can do is look to see, what does this portion of the leg equal?
4.
The whole thing is 4, so this portion right here is half of it, so 2. So let's break that figure down into a right triangle here. We have our height of unknown side, and we have this length of 2. Is there a way to find any other piece of information from this? Any ideas on where to go from here? Juan?
Isn't the height of the pyramid 10 centimeters, so we already know?
So now,
never mind.
Wait, now we want to look at that. The height is this measure from here all the way to here.
Can you give me the triangle?
So we know that this is 10. Good. So if we make another triangle right here on the inside, here's your right angle, correct? Is everybody able to see that kind of visually? Okay. So if this leg of the right triangle is 10, do we know what this leg is?
4.
No?
No.
I heard somebody said it. 2.75, that's the apothem, right? So it's what we just found down here. So this measure is the 2.75. So how can we find h? Yeah. So now we're going to use Pythagorean theorem one more time. Okay, so we're going to take this quantity and do what with it? We're going to square that. We're going to add it to 10 squared. And then what are we going to do with that result? Take the square root of it. And that gives us this, what's called a slant height. And it's just this height along this, along the lateral face of this pyramid. So we get approximately 10.37 for this height. And so now can we find our total surface area? Yeah, we have now all of our pieces. We can just calculate this through. So I'm going to go through and just multiply it from left to right, even though, again, like really I would just take and start from right here and work back. But we have 1/2 times 4 times 2.75, so I'm not going to abbreviate it or approximate it. I'm going to use the exact answer, times 5. And then to that I'm going to add 5/2 times 4 times this 10.37 answer, which is, again, right above, so I can go select it. And when I hit enter, I'll have my total area, and it'll be 131.25 approximately. The units are centimeters. It's a two-dimensional measurement, so square centimeters would be our answer.